This is GATE 2019 electrical question number 20. It says a coaxial cylindrical capacitor. This is the capacitor shown in figure 1. So at first it is given that it has a dielectric with relative permittivity of 2. Here you can see epsilon R1 relative permittivity is given to be 2, and the coaxial cable is fully filled with this material with relative permittivity 2. It is given in the question. Now it is said that 1/4 of the dielectric is replaced with another dielectric of relative permittivity. So 1/4 portion is replaced by another material whose relative permittivity is ER2, and the remaining is as it was in the previous case. It is 2, epsilon R1 equal to 2. So we are asked to find this value, and it is given that the capacitance in figure 2 is twice as in the previous case. So we need to solve this problem. So first, in order to solve this problem, we need to know the capacitance of a coaxial cable is given by 2 pi epsilon, where epsilon is the relative permittivity times permittivity epsilon naught into L by ln R by R, where R is the outer radius and small r is the inner radius. So we need to remember epsilon naught is permittivity and epsilon R is relative permittivity. Of any medium, and epsilon naught is the basis, that is the permittivity of free space or vacuum. So now we are given this useful data, and using this we will be able to solve the question. So first, it was given in figure 1. You see the capacitance we are now finding in figure 1. Okay, so in figure 1, this was a coaxial cable. Outer radius was bigger r and inner radius was small r, and this material with which it was filled, this has a relative permittivity given to be as 2. So capacitance in first case, let it be denoted by C1, is given by 2 pi into epsilon, where epsilon is the permittivity, times length of the cable divided by ln outer radius by inner radius. So as you can see, we are determining in the first case the capacitance to be like this. Now we are given with the information that epsilon is epsilon naught times epsilon r, which is 2 from here, times L, length of the coaxial cable, divided by ln r by r. So this is case 1. Now in case 2, we are told that the capacitor 1/4, so 1/4 to be filled with epsilon r2, and remaining 3/4 epsilon r1 equal to 2. So capacitance in second case should be addition of two components, because These two capacitance are in series and series capacitance are added. Imagine these to be different, this part to be different and this part to be different. Okay, so then these two parts net capacitance of this figure will be the addition of individual capacitances. So first consider this part, this shaded part. This is 1/4. The area becomes 1/4. So a capacitance also becomes 1/4 of the whole capacitance, and we are given 2 pi epsilon is epsilon naught into epsilon r2 times L is same divided by ln r by r, but since it is 1/4, a 1/4 factor will come. Similarly, in the second case, this part's capacitance is 3/4, so 2 pi into epsilon naught into r er2 is 2 epsilon r. For the second case, this part's relative permittivity is given to be as 2 times L divided by ln r by r, but since it is 3/4, a 3/4 factor will come, so we need to multiply with a factor of 3/4. Now this would be the net capacitance of the second case. So taking 2 pi epsilon naught L by ln r by r common, we are left out with 1/4 plus 3/2. Sorry, it will be, yes, 3/2. And in the first case it would be 2 pi epsilon naught L by ln r by r. We are taking common and it will be 2, and it is given so when we will be taking 2 pi epsilon naught L by ln r by r, epsilon r factor will also come here. Okay, epsilon r factor will also come. Now it is given that C2 is equal to 2C1. This fact is given. Now using the relation C2 equal to 2 times C1, so C2 is 2 times C1. Now C1 is 2 pi epsilon naught L divided by ln r by r, so 2 times that, so 2 times this factor. Now 2 pi epsilon naught by ln r by r is coming common, so 2 times C1, so 2 times 2, this part is common, so it's cancelled, equal to C2. So after cancelling this part, it will be epsilon r by 4 plus 3/2. So now 2 into 2 is 4 and 3/2 is 1.5, so 4 minus 1.5 is 2.5 into 4 is the value of epsilon naught. So epsilon r is 2.5 into 4 equal to 10. So this will be the final answer of our question. As we were asked to find out the value of epsilon r2, this is the value epsilon r of that medium, that 1/4 of which it is filled. In the second case, this is the value of that relative permittivity. So here 2 is coming out to be 10. Okay, so this is the answer. Thank you.